Okay, folks, we're moving on from Newton's third law, where all of those force pairs are always balanced, to thinking about Newton's first law, where if things are going to change, then we need to have a resultant force. So sometimes these forces will be balanced, and sometimes they won't be, but it's important to remember that this is Newton's first law, where you've sometimes got a resultant force, so sometimes there's an overall force pointing in a particular direction, and not Newton's third law, where those force pairs are always equal and opposite. I've attached the link for this again, and I just want you to have a little bit of a play with this again, really, but thinking about slightly different things. When I've got equal forces on both sides and press go, the sum of the forces is 0, so there is 0 resultant force, so nothing goes anywhere. The motion doesn't change. You need to be a little bit flexible with recognizing some of the different ways that we say resultant force. So in the textbook and in an exam, the word that they most often use is resultant force. But you need to be able to recognize things like the sum of the forces, which is what this is using here, or overall force, something like that. Okay, all these words mean the same thing, but you need to be able to spot them so that you can recognize what you're being asked. So if we go to, say, this situation, because we've got the same force twice on this side, we've got 50 newtons plus 50 newtons, we can represent that as 100 newtons. We've got 50 newtons going to the right, so overall we're left with 50 newtons going to the left. Because of that, it's going to move to the left. The difference between the forces, the resultant force going to the left, isn't very big. It's only 50 newtons. So the acceleration, the rate of the increase of the speed is quite slow. It takes a long time for them to get from the middle over to the left. We don't need to have two little forces to make 50. We could have just one big force that straight away got a value of 100. In which case that will do the exact same thing. It doesn't matter that you've got two little forces or one big force. What matters is the value at the end. In the same way that we had two of the same force, so two little people, 50 newtons, pulling like that, we've got a sum of forces of 0, so it doesn't go anywhere. We could do that. So we've got 50 newtons plus 50 newtons giving us 100 newtons overall, is the same as pitting it against 100 newtons straight away. Okay, so one big force of 100 newtons is the same as two little forces of 50 newtons working together. If you've got quite a lot of time, if you've got through the previous stuff quite quickly, you can have a little bit more of a play with this. You could look at how a big force pulling to the right, so that accelerates very quickly and red wins very quickly because there's a full 350 newtons pulling to the right. How that compares to, say, let's go for that situation. So we've got 50 newtons overall pulling to the right now, so it takes a lot longer to get up to get this speed increasing, and it takes a lot longer to get the trolley from the middle over to the right hand side. So as I say, have a play. You should have started off with this video, and then have a little go at the quiz questions. If you've got time for the extension, this is the sheep catching game, or the sheep launching game. You've got 3 levels: novice, advanced and expert. I suggest whatever you're doing, start off with novice just so you understand how it works. If you reckon you've scored a pretty high score, take a screenshot, send it to me. I'll give you a praise point. It works like this. Start on novice. Click start. You have to drag this Velcro board around the sheep. The numbers don't really mean anything. Okay, so don't worry about those numbers. Just think about the direction. Sheep floating in space. Not sure where these forces are coming from, but there is a force of 1 Newton on the sheep to the left. There's a force of 3 Newtons on the sheep to the right. So it is going to go to the right. As soon as I push launch sheep, it moves in that direction. If you want to mute it, because the sound of the sheep does get quite annoying after a while, just click that. Similar situation now. 1 Newton to the left, 5 Newtons to the right. Overall, that's going to be the same as 4 Newtons to the right, because that 1 Newton pulling to the left is going to cancel out with one of the Newtons on this side, but we've still got 4 Newtons left over. If the Velcro wall is in the direction that you need it already and the button doesn't appear, just give it a little wiggle, and then it will appear. Same again. This one a little bit different. We've got 2 Newtons going upwards, 2 Newtons going downwards. Those are going to completely cancel out. So that's going to have no effect on the sheep whatsoever. It's got 2 Newtons to the right and no Newtons to the left. This is very easy. I don't have to move this at all. So it's just going to end up going in the same direction again. Whichever difficulty level you start off on, the questions get a little bit harder as you go on. Eventually you get questions where the arrows are not pointing up, down, left or right, they're pointing in funny diagonal directions. You get questions where, well, not like this one, you get questions where the forces don't necessarily cancel out in a really tidy way. So for instance, you get something where, let's ignore this force here, the 2 Newtons to the left, you get 2 Newtons that way and 2 Newtons that way. So which way do you think it would go if it had something pulling it to the right and something pulling it down? That's a bit more advanced. If you're looking at triple or higher, then you need to know how to figure out the value of those forces, but we'll do that in another lesson in the future. Okay, have fun.